So hello everyone, we are now proceeding to our next topic, which is strain. So after this topic, we can now proceed to solve problems in mechanics of materials. So doon na natin i-apply itong mga diniscuss natin na to, no? Through problem solving. So let's begin. So yung una, ito, no? Sabi dito sa una, strain in general is a geometric quantity that measures the deformation of a body. So it is given by the unit deformation, or yung length of deformation per unit length of that material. So we'll discuss that further. So meron tayong dalawang types of strain or klase ng strain. Yung una is si normal strain, and yung pangalawa si shear strain. So, ano pinagkaiba ng dalawa na yan? So, si normal strain characterizes changes in dimension or dimensional changes. Yung paghaba, pag-iksi, ganun. And si shear strain naman describes distortion or change in angles. Itong pagpaling-paling, ganun, ano? Or pagkakahiwalay ng hindi parehong angle yung hati. Ganun. So, yun yung mga example nun. Or yung biglang tumabingi, yun, change in angles. So, the relationship of strain to stress defines the mechanical properties of a material. So, yan, ano. So, later on, we'll discuss this preceding topic, stress-strain diagram. So, ayan, ano. May relationship talaga itong si stress and strain. So, the knowledge of which is of the utmost importance in design. So, hindi lang si stress ang kino-consider natin when we are designing solid materials or structural members. So, itong si strain ay ang kabiyak nitong si stress na dapat nating i-consider when we are designing. Yun. So, let's proceed to axial deformation, stress-strain diagram. Yun. So, the strength of a material is not the only criterion that must be considered when designing machine parts or structures. Hindi lang yung strength, hindi lang yung capacity niya, no, or yung loads na kaya niyang dalhin. So, often equally important, or mas importante rin daw, na kino-consider is yung una, stiffness of the material or yung katigasan ng material. So, as are mechanical properties. Ano ba yung mechanical properties na yan? Ito yung pag-aralan nyo nung elementary tsaka high school, ano? Hardness, toughness, and ductility, and so forth. Yun. So, yun yung mga kino-consider natin when we are designing materials. So, proceed tayo, no? So, normal or axial strain. So, dito muna tayo magpo-focus kay normal strain. So, consider the elongation of the prismatic bar in the figure with a given length L. So, consider daw natin to, no, yung elongation ng prismatic bar, the figure. So, nasaan yung elongation na yan? So, elongation is given by this delta x, yan. Yung change in length or this delta sigma. Yan. The elongation, yan, sigma, no? So, ayun, sigma yung elongation or gamma pala, no, gamma may be caused by an axial or an applied axial force. Yan. So, correct ko, elongation is given by the symbol gamma. Yan. May be caused by an applied axial force or an expansion due to an increase in temperature increasing or acting simultaneously. So, ayan, ano, may typographical error lang ng konti, pero neglect nyo na lang. Yan. Increase in temperature, increase. Yan. So, maybe not, ano? Kasi matagal ko na rin itinipe to. Maaring ang ibig sabihin niya dito ay mabilis na pag-angat ng pagbabago ng temperatura. Ayun. Na nag-act simultaneously. Yan. So, yun daw yung ibang causes ng elongation. Pwedeng applied axial force or yung external load, or maybe due to expansion due to an increase in temperature. So, di ba, na-discuss ko rin yung kung ano si creep and kung ano si expansion due to temperature changes. Yun. So, kagaya ng mga steel, ano, or like steel, or meron ding ibang materials na nag-expand due to increase in temperature. Yan. So, do some research regarding those materials. So, ano ba nangyayari kapag nag-expand ang steel? Obviously, nagkakaroon ng deformation. And conforme sa expansion niya, no? Well, obviously naman, kapag sinabi mo mag-expand, lumapad. Ano? Lumapad, lumuwang, humaba, ayun. So, that is expansion. So, strain describes the geometry of deformation. Tatandaan na, strain describes the geometry of deformation. And it is independent of what actually causes the deformation. Ano? And strain is given by the symbol. Ito, no? This symbol. The normal strain is defined as the elongation per unit length. Yun nga yung sabi ko kanina, no? Elongation per unit length. And therefore, the normal strain in the bar in the axial direction, also known as the axial strain, is given by this formula. Strain is equal to elongation gamma over the unit length L. The formula is highlighted for you to know, no? Na dapat niyo siyang i-take note. Okay. Elongation over unit length. So when the bar deforms uniformly, then strain is equal to elongation over unit L. Yan. Ito. Represents the axial strain everywhere in the bar. So kapag daw uniform ang deformation, so ibig sabihin yung pangkalahatan or yung buong katawan ng bar, no, or nung prismatic bar na to ay nakakaranas or nire-representa ng iisang strain lamang. So kahit saan mo tignan yan, kapag daw uniform ang deformation, meron lang iisang strain na nararamdaman dito sa buong cross-section or buong kahabaan nitong bar or ng prismatic bar. Otherwise, itong expression na to should be viewed as the average actual strain. And the normal strain is a dimensionless quantity. So, bakit siya naging dimensionless quantity? So, kung titingnan mo yung formula ng strain, which is elongation over unit length, ano ba yung ginagamit nating unit kapag sumusukat tayo ng deformation? Like elongation or shortening. Diba, sinabi ko, we use units of length like millimeters. Ganun, ano? Kasi napakaliit lang naman ng deformations, ano? Kagaya ng elongation and compression kung titignan mo. Sometimes, it can't be viewed by the naked eye. So, halimbawa, ano daw yung hinaba niya per unit length? So, yun yung unit length is measured also by a unit of length, obviously, like millimeter. So, kaya siya naging dimensionless quantity. Ibig sabihin lang ng strain, ano yung hinaba niya or iniksi niya per unit length per se, no? Halimbawa, sa first millimeter niya, sumaba siya ng halimbawa 0.5 millimeter. O yun yung hinaba niya dun sa first millimeter niya pag sinukat mo siya from 0. 0 from 1 end. O yun lang yung ibig sabihin ng strain. Yung hinaba niya per unit length. Ayan, paulit-ulit na, no? However, units such as inches per inches, ito nga yung sinasabi ko, or millimeter per millimeter are frequently used for normal strain. So, ayan, ano, kapag kinancel mo nga naman yan, dimensionless quantity. So, okay lang kung halimbawa ang sagot niyo sa quizzes or exams is a dimensionless quantity, I suppose, ano, or I must say. Or, di kaya naman, ay may unit kagaya nito. Inches per inches or millimeter per millimeter. Just be constant or be specific sa paggamit. So, if the deformation is not uniform, ayun, pag hindi daw uniform ang deformation, define strain at a point. No? So, i-consider mo daw yung strain at a single point. So, galing daw sa figure na to, let capital letter O, no? Itong O na to, ito yung una, yung nandito sa undeformed state. A point in the bar or be a point in the bar located at the distance x from the fixed end. Ito. So, ito na. Tingnan yung undeformed state. Meron ka daw point O located at a distance x from the fixed end. So, ito, no? Yung distance x. Ayan. Yan, yun yung distance x. Ito naman yung fixed end mo, no? Yan, yung part na yan. So, to determine the axial strain at point O, para daw malaman yung axial strain sa point O, kailangan may consider yung deformation ng isang imaginary element or a fiber. O, kuha ka daw ng isang piraso ng hibla niyan. Fiber OA. Ano? Halimbawa, ito. Kumuha daw siya ng OA. So, ito daw yun. Ayan. Tignan nyo mabuti. Yan. Yan daw yun. Yung O to A. Of length delta x. So, yung fiber OA daw na kinuha niya ay may habang delta x. So, ito yon yung pinopoint ng arrow. So, nasan yung delta x? Obviously, ito. Yan. That is embedded in the bar at O. Sa point O, no? So, denoting the elongation of OA by delta gamma, no? Define the axial strain at point O as, so ito, magde-derive tayo ng formula. Delta gamma over delta x, no? Or the limit of delta gamma over delta x as delta x approaches 0 will be equal to or is equal to delta gamma over delta x. So, para tayong nag-derivative. So, tandaan nyo yung formula na yan kapag hindi or non-uniform yung deformation dun sa isang material. So, pwede nating i-observe or observe nyo na yung normal strain is like normal stress. A normal stress is defined at a point in a given direction. Okay? Parang stress. Consider nyo daw siya like normal stress. Stress, no? Only at a given direction lang siya. So, take note, na kung yung distribution daw ng axial strain is known, kung alam mo daw yung distribution ng axial strain, yan. Yung elongation daw ng bar can be computed from this formula or through this formula. Well, actually, or supposedly, gamma, or the elongation, is equal to d gamma, no? 0, or from 0 to L, or the integral of d gamma from 0 to L is equal to the integral of strain with respect to x, no? From limit 0 to L. For uniform strain distribution, or the axial strain is the same at all points, no? It yields strain is equal to gamma over L. So, kung uniform daw strain distribution, ang formula na gagamitin mo is simply the formula gamma over L, which is the elongation over the unit length. Okay. Dali lang yan, direct substitution. So, yung results are also applicable to compression. Kasi by convention, yung compression or shortening or yung compression na nagre-resulta sa shortening only carries a negative sign. So, halimbawa, makakuha ka ng strain na may value na negative 0.002. So, yan yung sinasabi ko kanina na dimensionless quantity. But it can be said or it can be stated on either units such as inches per inches or millimeter per millimeter. So, kung halimbawa nakakuha ka daw ng ganitong value, may negative value, ibig sabihin lang daw nun, meron kang compressive strain of magnitude 0.002. Kasi 'di ba ang principle lang naman ng tension and compression ay magkabaliktad. Okay? So sign conventions lang nakaiba. So pwede mo ring gamitin ito kay compression. Ayan. So tatandaan. So ayun. After discussing what is axial strain, punta tayo kay tension test. Okay. So we'll be using this figure, no? Yung specimen used in a standard tension test. So, ano nga ba si standard tension test? So, sa isang standard tension test daw, meron tayong specimen, which is represented by this figure. Yung specimen daw na yun is placed in the grips of a testing machine. So, kung hindi pa kayo nakakita ng testing machine, meron ditong testing machine. Ayan. So, in this case, ang pinaste ko dito sa document is a universal testing machine. So, si universal testing machine kasi, pwede kang mag-test sa kanya ng tension and compression. So, pwede ring hiwalay yan. Pwede ring meron kang separate tester or separate material tester just only for tension and one only for compression. But with the universal testing machine, you can test both tension and compression. Yan. So, ayun. Back to the discussion. So, the grips are designed. Yung mga hawakan daw na yan, ayan, ito. Ito yung mga hawakan na yun. Ayan yung grips. Diyan mo daw isasangat yung specimen. So, dinisenyo daw yan so that the load P applied by the mechanical is axial. So, obviously, the tension test is the testing of materials when applied by axial loads. So, tension test. So, ang tetest mo dito ay tension, obviously. So, meron tayong 2 gauge marks. Ayan, na-inscribed on the specimen. O, nasan yung gauge marks na yun? So, ito yan. To define or in order to define the gauge length. So, halimbawa, dito ka naglagay ng gauge mark. Ayan. So, ito daw yung gauge length mo. Gauge length of unit L. So, yung marks daw na yan are located away from the ends to avoid the local effects caused by the grips. Kasi itong mga parang roscas na to, yan yung isasangat mo sa grips. Yan. Yan. So, dapat, kapag nag-set ka ng gauge length, medyo malayo dun sa may pinakadulo niya, no? Para tamang-tama yung lalabas dun na resulta sa may testing machine. Yan, no? Caused by the grips to ensure that the stress and strain are uniform. So, pantay, ano? In the material between the marks. Makakakuha ka ng uniform strain, ano? Or ng resulta na merong uniform stress and strain dito kung saan ka nag-set ng gauge length. So, dun sa Canvas page, merong discussion na nakalagay dun. So, meron dong example ng universal testing machine or video about sa universal testing machine. Its parts and its uses. So, I suggest to watch that video. Yan. Okay, proceeding, the testing machine elongates the specimen at a slow, constant rate until the specimen ruptures. So, itong tensile testing machine, no, pinapahaba niya yan or binabatak na ng binabatak yung specimen dahan-dahan. So, bakit dahan-dahan? Kasi nakakonekta yan sa isang monitor. Tapos, yung monitor na yon is nagpapakita or nagre-record ng kanyang results. Ano yung result na yon? So, ang result na yon is yung stress strain diagram na tinatawag. So, we'll discuss that shortly after this. Yan. So, kapag habang binabatak mo siya, dapat yung bilis ng pagbatak niya, no, is constant. Yan. Until the specimen ruptures. So, babatakin mo siya ng babatakin hanggang sa masira yung material. So, during the test, continuous readings are taken of the applied load and the elongation of the gauge length. Yan. So, paano yung continuous readings na yan? Actually, via or through the monitor na sinabi ko kanina. May computer kasing nakakabit dyan sa tabi niyan. Yan. Yun. Pati yung elongation ng gauge length, sinusukat din ng computer yon. Yan. Which are then converted to stress and strain. Ayan. So, the results, which are based on the original area and the original gauge length, are referred to as nominal stress and nominal strain. So, tatandaan. So, mas ma-appreciate nyo kung ano si universal testing machine kapag pinanood nyo yung video na nakalink dun sa may discussion sa Canvas. So, the cross-sectional area becomes smaller and the length between the gauge marks increases as the bar is being stretched. So, common sense, ano? So, tingnan mo itong gauge length. Ayan. So, habang hinahatak mo daw yan, constantly, slowly and constantly, or at a constant rate, yung gauge length na to is obviously hahaba, di ba? Magkakaroon siya ng pagbabago sa kanyang length. Ayan. Bawa, ganyan siya humaba. Tapos, pansinin mo, yung cross-sectional area nito, hindi na siya ganyan. Actually, kapag tinignan mo siya, para siyang numipis like this. Di ba? Kasi, habang binabatak mo siya, unti-unti, nagmimistula siyang parang rubber band or parang laste. Hindi siya basta-basta mapuputol. Unti-unti muna siyang mag-i-stretch hanggang sa mag-rupture yung specimen na yan. So, kapag nakakita kayo or nakapanood kayo ng lab technician na nagko-conduct ng tension test, lalo na sa mga malalaking diameter or malalaking reinforced steel bars, ano, or mga kabilya, biglang puputok yan, ano, kapag naputol yan. Puputok yung malalaking bakal. Halimbawa, 32 mm yung tinest mo. So, sobrang taba nun. Tapos, binatak mo siya ng binatak. Kapag nag-fail yan, kala mo may nagpaputok ng baril. So, for the benefit of all of you, hanap ako ng video about doon, ano. So, let's proceed. So, tatandaan nyo yung sinabi dito, ano? Cross-sectional area becomes smaller and the length between the gauge mark increases. Yan. So, para daw ma-solve natin yung true stress, ayan, true stress, ano? I-divide mo lang daw yung load by the actual area of the specimen. So, kung ano yung load na pumasok or in-apply mo dito sa specimen mo, i-divide mo lang daw dun sa actual area niya. Bago mo siya isalang. Ayan. So, yung true strain is obtained by dividing the elongation naman, elongation gamma by the current gauge length. So, yung elongation niya, sukatin mo to, kung ano yung hinaba niya, over dun sa pangkasalukuyan or kasalukuyang haba nung gauge or yung gauge length. Yan. So, therefore, you'll have the formulas stress equals P over A and strain is equals to gamma, which is the elongation over the unit length L. Ano? Yan. So, tatandaan nyo to, no, kung paano gumamit ng or kung paano mag-solve ng true strain and true stress using the universal testing machine or the tension testing machine. So, the nominal and true measures, yan, are essentially the same in the working range of metals. So, nagkakaiba lang sila for very large strains, kagaya ng rubber-like materials, yan, or in ductile metals just before rupture. Yan. And plotting axial stress to axial stress results in a stress-strain diagram na tinatawag. So, ito na yung sinasabi ko kanina na stress-strain diagram. Kapag ito daw ay na-perform mo properly, yung stress-strain diagram for a given material is independent of the dimensions of the test specimen. Ayun daw ay yung characteristics of the diagram ay dinedetermine solely by the mechanical properties of the material. So, ano nga ba yung explanation sa likod na itong stress-strain diagram? Ano ba yan? So, look at the figure here or the graph here. Yan. Ito ay sample stress-strain diagram na na-obtained from a standard tension test on a structural steel specimen. Ano ba yung structural steel specimen? So, ayan yung mga ginagamit nating mga steel when we are constructing structures, obviously. So, yan. Matitibay itong mga steel na to, no? So, dito sa graph, sa y-axis or sa vertical axis niya, we have the stress. And then sa horizontal axis niya or sa x-axis niya, we have the strain. So, kung makikita nyo nga daw, habang tumataas yung stress, tumataas din yung strain. Ayan. So, ipapakita ko lang naman muna dito si stress-strain diagram. So, the stress-strain diagram has these points called the yield point, the elastic limit, proportional limit, the ultimate strength, true rupture strength, and nominal rupture strength. Actually, I have prepared another video discussion next to this one, ano? Ang katuloy nito is yung further explanation nitong stress-strain diagram. So, I suggest to watch it also. It's for the benefit of you naman, ano? Yan. So, let's proceed. Meron tayong tinatawag na true stress-strain curve. Ayan. So, si true stress-strain curve, makikita nyo through this line. Ano? Ito. Yung red line na to, na nakakonect dito sa red na imaginary or broken lines. So, yan yung true stress-strain curve. So, don't worry. I have prepared another video discussion of this. So, ayan. So, I suggest to watch that discussion. So, ayun. Ito lang naman yung mga example ng isang test specimen. So, dito sa pinakababa, meron tayong broken specimen. Ito, nasa may top figure. Ayan. Yan ay isang broken specimen. So, kung makikita nyo, malapit na siya sa kanyang breaking point. Yung mapuputol na talaga siya. Ito yung sinasabi ko kanina, no? Na nagbago yung kanyang gauge length. Ayan. So, sa pagbabago ng kanyang gauge length, humaba siya, no? Humaba siya. So, ito yung delta L mo na, no? Or the change in its initial length. And kung papansinin mo, habang humahaba rin yung gauge length, ayan, lumiliit din yung cross-sectional area niya. So, this is a broken specimen. So, yung gauge length na sinabi ko kanina is itong mga guhit na to. So, ayan, nag-set siya ng mga gauge lengths. So, nung sinukat ngayon siya or nung sinalang siya ngayon sa may testing machine, ayan, pinakagat siya dito sa mga grips ng testing machine. Tapos, nung in-apply na yung loads, dito siya nag-fail sa may bandang gitna. And dito naman sa baba, nung naunang figure, is a test piece or undeformed test piece. Hindi pa nasasalang. Ayan. And dito naman sa may taas na graph, ito yung effect of specimen geometry on tensile testing results. So, ayan. So, we'll discuss this further pagdating dun sa another video. Medyo mahaba na kasi. Masyadong malakas kumain sa data. So, yuntuin lang natin. So, that is all for this discussion. Thank you and I hope you watched it until the last part of the video.